Hello. This week we're going to be working with proving that triangles are congruent. We spent quite a bit of time discussing exactly what makes shapes congruent. Okay, one would be able to lie directly over the other, meaning all sets of corresponding angles and sides would be congruent. Okay, what we need to focus in on now is how much of those triangles have to be marked congruent for everything to align in those shapes and for that to work. We have special cases or theorems that we use to show that triangles are congruent without having to name all 6 parts, 3 sides and 3 angles. So we're going to spend some detailed time going through those and then really kind of practice with writing proofs out this week. Okay, let's go ahead and start taking a look at our notes to see how that would work. All right, so in this first lesson this week, we're covering chapter 4, lesson 3 and 4 kind of together. We're looking at a couple different congruency cases there, but we need to get some definitions put into play. First of all, what makes an included angle or an included side? Because we need to have specific parts in specific order, okay, when we start looking at our proofs. So if we have an included angle, okay, we want to make sure that that angle is the angle formed between 2 sides. Okay, so those 2 sides meet at the vertex of the included angle. If it's an included side, it's the side between 2 vertices for angles. Okay, so those endpoints of the sides of that included side is going to be the vertices of your angle, okay, and right in between. So let's take a look at what that actually looks like. So in this first example here, A, we're asking if we can name the included angle between these 2 congruent sides. So LM, which is right here, and LK, which is right here. If those are my 2 sides, they each meet at this vertex here, L, so that would make angle L the included angle. If we use these 2 sides, MN and MK, okay, right here, then between those 2 sets of sides, they meet at vertex M. So angle M would be considered to be that included angle. Okay, if we look at it the other way, name the included side now between 2 angles. So I might want to kind of just redraw this picture here, just to make sure I've got some markings on the original. Okay, so now if I take angle LKM, so L to K to M, that's this angle located here in this location, and then angle L to M to K, which is this angle here. What I really want you to do is think about it as marking those vertices, because then the side formed by those vertices or endpoints is the included side. So here that would be side KM, would be that included side between the 2. But look at the vertices of your angle. Those become the endpoints of that included side. But it looks like then we have that in order. We have a side included between 2 angles. So it would be an angle, a side, and an angle. Okay, or here on my diagram, it would be a side, then an angle, then a side. Okay, kind of in that order as you work your way around the triangle itself. All right, we're going to look at how these 2 triangles could be congruent. Now in this picture, it just looks like a reflection where one triangle would flip and fit perfectly over the other. And if all of these three side lengths are exactly the same, they should match up with these three side lengths over here. Okay, should definitely work. This is what's called our side, side, side postulate. Okay, we abbreviate that as SSS, okay, within our proofs when we start to work with those. Okay, so a couple of things to keep in mind here. If you're using side, 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 you have three sets of sides that are going to be congruent to three sets of sides on the other triangle. If that's the case, then I can say that the triangles are congruent. So then I would write my triangle congruency statement. So triangle P to Q to W, okay, if that was my first one. And then again, you want to match that up correctly. So if I look at this as that reflection, angle P would align with angle T. Then Q would align or correspond to angle S. Okay, and then W with W. Okay, so if you have three sets of sides, that's always enough for your triangles to be congruent. You should know this as we kind of looked at that construction. If you're given three lengths, there's only one location for that third vertex. So only one way that that triangle could be drawn. So these would have to be congruent to each other. Okay, so there's our first case for congruency, side, side, side. Now, our next two involve that included angle or side piece. So if we have the SAS, okay, postulate, that stands for side, angle, side. Okay, on a picture, it has to look like it's in that exact order. You have to have two sets of sides with the included angle, the angle in between. So when I look at the triangle, it goes in that order. It goes from a side to an angle to a side as I work my way around, okay, and that matches up. But again, I can see that these two sides meet at vertex E, so angle E is the included angle between those two sides. Okay, now here, I can tell in this picture that this one is a rotation. I've taken this triangle and rotated it on top of the other, okay, to kind of create that congruency. Okay, think about that rotation when you're writing your congruency statement to make sure that these match up. So my first triangle here, A to B to E, will be congruent with, okay, angle A would turn to angle C. Okay, angle B right here would turn to angle D, and then E with E, and you can see those are marked congruent already, okay, in there, so then that would be my congruency statement. So if you have a side, then an angle, then a side, in that order, okay, then your triangles have to be congruent. The reason this one works, remember, is that your angle measurement here would create the length of the side opposite it. So the same angle measurement would create the same length for your side, and then you'd have three congruent sides again. So this would certainly work, okay, to create congruent triangles. And then your last case is your angle side angle case. Again, have to be in this order, angle, side, angle. Okay? If that's the case, then we have two angles with their included side on each triangle that will work. So as we have it marked on this picture here, it goes from an angle to a side to an angle, all in order there. Or you can see the two vertices of your angle create the endpoints of that side, making it an included side. Okay, if that's what's marked on each one, angle, side, angle, angle, side, angle, okay, then these are going to be congruent to each other. So I could make this first triangle, triangle HEA, and that will be congruent to And again, I just want to look at how these would work. And again, this would be a rotation. This triangle would turn to this one. And we can see that H would then become angle R, or correspond with angle R. Okay, E is going to rotate to T, and then A with A. Okay, what you want to do as we start looking at further examples within this lesson is look to see if you don't know all three sides and all three angles, okay, in two triangles, you want to see if it fits one of these special cases to create congruency. So as we look at this next step, we want to decide if there's enough information here marked, because I don't have everything marked congruent. Is there enough to determine that the triangles are congruent? Okay, if it is, there should be a postulate that it matches up to. Okay, so in this case here, we want triangle MAE, okay, which is this triangle here, with TAE. Okay, well, I should see that I have one set of sides here. I have a second set of sides here. And then they have that shared side, AE, in the center. So AE is equal to itself because it's already lying one on the other in this diagram. That's your reflexive property when we start writing the proofs out itself. So anytime there's a shared side or angle, then your reflexive property would allow you to make those equal to itself. And if that's the case, now I have three sets of sides that are congruent on each, okay, or in this diagram between each triangle. So this would be our case for side, side, side. So yes, they would be congruent. Okay, in number 2, we have triangle RUS and TUS. Okay, we should notice that we do have a shared side again, side US. So that would be equal to itself. Okay, or right now, one's lying right on the other. Those do align or match up. Now, I notice in this case that I have two sets of sides and an angle. However, the angle marked here, R and T, is not the included angle. And you want to kind of look at your picture. This angle would have formed the length of this side. Well, we already know that that's a congruent set of sides. What I don't know is side RS, but there's no way because I don't know what this angle measurement is here. It's not marked. So here there is just not enough information to prove congruency. It looks like congruency, but I don't have a way to prove that, okay? Because that angle is not the included angle, so it doesn't fit, okay, into our side angle side postulate. Okay, if we look at this third scenario, again, shared side in this figure, and that would give me three sets of corresponding sides. So again, by side, 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 I could make these triangles or prove that these triangles are congruent. Okay, in number 4, all I have is the shared side down the center, okay, of that diagram, but I only have two sides. I don't have the third, and I don't have any angles, okay, marked to kind of help me. So again, not enough information, okay, to prove that those would be congruent. Okay, something interesting here happens in number 5 because this is going to review some concepts from earlier in the year. Okay, we do have a set of sides marked congruent. We do have a shared side, so MT would line up with MT. And now we have these little arrows marked on here showing that we have a set of parallel sides. Well, if you have parallel sides, we should be looking for, in this type of diagram, alternate interior angles. So I kind of look at where those would be located. So I want to think about this side here in the center as my transversal between those lines. So that will make this angle here congruent with this angle here. Okay, if my lines are parallel, alternate interior angles are congruent. And I would now have side angle side as I go around the triangle, okay, or on the other one, side angle side. That is one of our congruency cases. And again, the angle is included. It's the one between the two sets of sides. I see they meet at vertex M or meet at vertex T. So those are included angles. So yes, these can be congruent. All right, so what we want to do when we're actually writing out a proof for congruency, okay, we want to make sure that we mark the diagram with any given information from the beginning. Okay, usually have it listed in the given, okay, or it might already be marked on the diagram, okay, either way. Then what you want to do is mark any additional pieces of information that you know. So some key things to kind of look for are shared sides or angles, because if they share them, one lies directly over the other already, they're congruent. Okay, or vertical angles, okay, or angles from parallel lines like we just had in our last example. Okay, those are kind of key things that we have previous knowledge about that we can now mark on the figures themselves. Once you've marked your diagram within a proof, you immediately want to determine which case you would be using. So we have 3 different cases that we can use to prove congruency. Side, 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 angle, side, or angle, side, angle. Okay, then what we want to do is make sure that all the congruent parts are stated in the proof before we make the proof statement. So if you're going to use, let's say, side, 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 there's 3 pieces of information that need to be stated. You have 3 sets of sides that have to be stated before you can make your congruency statement. Okay, or for instance, if we were using angle, side, angle, we have 2 sets of angles and 1 set of sides that would have to be stated before we can make our congruency statement for the triangle. And then the end of the proof should always be that congruency statement. Okay, once you kind of get the feel for how your triangle congruency proofs are set up, they kind of follow that order each time and you want to work with it that way. Okay, so if we look at this proof here that we have in example B, let me make this just a little bit bigger. All right, we are going to start always by listing our given information. Okay, and let's mark that given on the diagram. So we were given that LM will be congruent to PN. And LP is congruent to MN. Okay, those 2 pieces of information were already given. So I already have 2 sets of sides that are congruent. When I look at my diagram here, I should see that they share side PM. So it will be equal to itself. And you can see that that's the next thing marked in my proof. PM is congruent to PM by our reflexive property. Okay, because it's equal to itself. And then I should see that I do have 3 sets of sides listed. So this will fall into my side, side, side congruency case. So my triangles are now congruent by side, side, side. And we can abbreviate that as just SSS. That's common notation that's used throughout our text to kind of describe that scenario. All right, let's just try one more. okay, as we kind of practice with these proofs once again. So again, proof has to start with your given information. Okay, so let's look and see what was actually given here. Okay, XW is congruent to YZ. Okay, so XW is congruent to YZ. Now, we did have a second piece of given information here that tells us that X is the midpoint of VY. Okay, so here's X. I know that's my midpoint of VY. Well, if I was going to mark that on the diagram, I know that a midpoint divides a segment into two congruent parts. Okay, so those two parts would have to be congruent to each other. Okay, and then my final piece of information here is that XW, which is this statement here, runs parallel with YZ. Now, if I look at those two parallel lines, okay, and you might want to kind of expand them a little bit in your picture, just to make it a little bit easier to mark. Okay, this would make this line here my transversal. So in this scenario, I could mark this angle here congruent with this angle here because those are corresponding angles. And I will say between parallel lines, what tends to fit in your diagrams are either alternate interior angles or corresponding angles. Okay, there's no alternate interior here because of the transversal we were using. Now this one's important here because this gives us the included angle between two sides. Now it goes from side to an angle to a side, side to an angle to a side. So I can say that these two triangles are congruent by side angle side as that case. Okay, so that first statement started our given information, but notice step 2 is also a piece of given information. But from that piece of given information, we knew that YX would have to be congruent to XV because a midpoint divides a segment into two equal parts. So that is our definition of a midpoint. And I know it's been a little while since we worked with our proofs, but again, that clue, when you use a vocabulary term in the proof itself, you're probably going to use that definition, okay, to further make a statement. Okay, so just kind of keep that in mind. And then here again, XW was parallel to YZ. That was another given piece of information. And now I have my 3 given statements. There can't be any more given, okay, within your proof. But we definitely don't want to miss those reasons. And again, from those parallel lines, we said that angle Y would be congruent to angle VXW because those were corresponding angles. So we have our corresponding angles postulate, okay, which tells us if 2 lines are parallel, then the corresponding angles must be congruent. Okay, and then I have this triangle congruency case. Now remember, we wanted to use side angle side. So you always have to look back within your proof to see if you listed these 3 parts. Okay, so here's my first set of sides. Okay, there's my set of angles. And then here's my second set of sides. So I've made these 3 congruency statements for the parts. So then that's enough to prove that my triangles are congruent by my side angle side scenario. Again, just a little bit of practice with these proofs. We're just kind of beginning that. We're going to continue to kind of work through that in the next couple lessons.